Hello viewers, in today's session we are going to discuss another important problem from beta and gamma functions, and here we are going to find out the value of this integral using the concept of beta and gamma functions. So we have to evaluate the integral 0 to 1, and we have dx over the sixth root of 1 minus x raised to 6, right? So let us first convert this integral I using the method of substitution to the beta function, which is given by beta m comma n is given by the integral 0 to 1, and we have t raised to m minus 1 minus t raised to n minus 1 dt. So the first step is to convert this integral by method of substitution to this integral, and then we'll apply the properties of beta and gamma functions, right? So let us take this integral as I, and here what we will do, we'll first write this integral I as 0 to 1. We have dx divided by 1 minus x raised to 6 raised to 1 over 6, and let us make this substitution, that is t is equal to x raised to 6, so that we can write x is equal to t raised to 1 over 6. Now let us differentiate x with respect to t. So we can now write dx over dt is equal to d by dt of t raised to 1 over 6. So using the method of power rule, that is the derivative of t raised to n is given by n times t raised to n minus 1. So we have n is equal to 1 over 6. So we have 1 over 6, then t 1 over 6 minus 1. So we have 1 over 6, and t raised to 1 minus 6 over 5, that is 1 over 6 t raised to here we have 6, and then we can write minus 5 over 6. So now we can write dx is equal to 1 over 6 times t raised to minus 5 over 6, and here we have dt. Now let us change the limits accordingly. So here x varies from 0 to 1. So when x is equal to 0, the value of t can be obtained from this relation. So we have t is equal to 0 raised to 6, that is simply 0. And when t is equal to 1, then we have t is when x is equal to 1, then we have t is equal to 1 raised to 6, that is simply 1. So when x varies from 0 to 1, then t varies from 0 to 1. So now let us write the value of this integral I in terms of t. So we can now write I is equal to 0 to 1, because the limits remains the same, and we have for dx we can write 1 over 6 and t raised to minus 5 over 6 dt, and in the denominator we have 1 minus t, because x raised to 6 is t, and here we have 1 over 6, right? So now taking 1 over 6 outside the integral, we have 0 to 1, and then we have t raised to minus 5 over 6, and taking 1 minus t raised to 1 over 6 to the numerator, we can now write 1 minus t raised to minus 1 over 6, and here we have dt. So now we can easily observe that this integral is similar to this one, that is the beta function, that is beta m comma n is 0 to 1 t raised to m minus 1 1 minus t raised to n minus 1 dt, where m and n are greater than 0. right? So here we have t raised to minus 5 over 6, and here we have t raised to m minus 1. So now we need to find out the values of m and n. So we can compare this integral with this one. Here we have an additional factor 1 over 6. So now m minus 1 can be written as minus 5 over 6, and n minus 1 can be written as minus 1 over 6. So let us solve these two equations. So we can now write m is equal to minus 5 by 6 plus 1, that is minus 5 plus 6 over 6, that is 1 over 6. So the value of m is 1 over 6, right? And from this equation we can now write n is minus 1 over 6 plus 1. So n is minus 1 plus 6 over 6, that is 5 over 6. So we can now write n is equal to 5 over 6. So now we can write this integral as 1 over 6, 0 to 1, and t raised to minus 5 over 6 is m minus 1. So we have m is equal to 1 over 6. So 1 over 6 minus 1, and here we have 1 minus t raised to minus 1 over 6. So minus 1 over 6 can be written as n minus 1. So we have n 5 over 6, and this is minus 1 and dt. So now this integral is exactly similar to this one. So we can now replace this integral by the beta function. So we have beta m comma n. M is 1 over 6 and n is 5 over 6. So now we have to find out the value of this expression. So to get the value of this expression, we'll make use of an important relation between beta and gamma functions. So gamma beta m comma n is given by gamma m times gamma n divided by gamma m plus n. So now using this relation, we can now write 1 over 6. Then we have gamma 1 over 6 times gamma of 5 over 6 divided by gamma 1 over 6 plus 5 over 6. So now we can write 1 over 6. Then this is gamma 1 over 6 and gamma of 5 over 6 divided by 1 over 6 plus 5 over 6 is 6 over 6, that is equal to gamma 1, and gamma 1 is equal to 1. So here we have 1. So now we can write the value of the integral I as 1 over 6 gamma 1 over 6 and gamma 5 over 6. Now to get the value of this expression, we have to make use of the famous Euler's reflection formula. And the reflection formula goes like this: gamma 1 minus n times gamma n is equal to pi divided by sine n pi, right? So if we take this n as 1 over 6, then we have gamma 1 minus 1 over 6, gamma 1 over 6, and here we have pi divided by sine n pi. So n is 1 over 6, so we have pi over 6. So now this is 1 minus 1 over 6, so this is gamma 5 over 6, and here we have gamma 1 over 6, and this is pi divided by sine pi by 6. Now sine pi by 6 is sine 30 degrees, that is equal to half. So here we have half, so this is equal to 2 pi, taking this 2 to the numerator. So the product of gamma 5 over 6 and gamma 1 over 6 is equal to 2 pi. So substituting this value over here, the value of the integral I is now 1 over 6 times 2 pi, and we can now cancel this 6 by 2. So we have here 2 times 3 is 6. So this is pi over 3. So viewers, the value of this integral is equal to pi over 3. So this is how, by making use of the concept of beta and gamma functions, we can easily evaluate integrals of this kind. Hello viewers, in today's session we are going to discuss another important application of beta and gamma functions to solve this given integral. So here we have to evaluate this definite integral that is from 0 to 1, and the integrand is square root of 1 minus x raised to 4, and here we have dx, right? So let us see how easily we can solve this integral using some important results from beta and gamma functions, right? So let us start, and let us first call this integral as I, right? And here let us briefly see the important results from beta and gamma functions which are going to be used while evaluating this integral. So here we are going to make use of the definition of beta integral, which is also known as beta function, or Euler's integral of first kind, right? So here the beta function is defined as beta m comma n, and this is given by the integral 0 to 1, and here we have t raised to m minus 1 and 1 minus t raised to n minus 1 and dt. And remember, m and n are greater than 0, right? So here by making use of the method of substitution, we'll first convert this integral into this one, right? And then we'll apply the relationship between beta function and gamma function. So the beta function and gamma function are related by this expression, that is beta m comma n is given by gamma m times gamma n divided by gamma m plus n. So apart from these two important results, we'll also make use of the famous Euler's reflection formula, that is gamma 1 minus n times gamma n is equal to pi divided by sine n pi, right? So these three important results are to be used while solving this integral, right? So let us first convert this integral into the beta function by making this substitution, that is x raised to 4 can be taken as equal to t. So here we are introducing the variable t, right? So we can now write x is equal to t raised to 1 over 4. Now let us differentiate x with respect to t. So we can now write dx over dt is equal to d by dt of t raised to 1 by 4. Now to get the derivative of t raised to 1 over 4, let us make use of the power rule for differentiation, that is the derivative of t raised to n with respect to t is n times t raised to n minus 1. So here our n is 1 over 4. So we have 1 over 4 t raised to 1 by 4 minus 1. That is 1 over 4 t raised to 1 minus 4 over 4. That is 1 over 4 t raised to minus 3 by 4. So 1 minus 4 is minus 3, right? So now let us write dx is equal to 1 over 4 t raised to minus 3 by 4, and here we have dt. Okay, so now here when we make use of the substitution method, we have to change the limits accordingly. So here we can see that the limits of integration vary from 0 to 1. So the lower limit is 0, the upper limit is 1. So when x is equal to 0, the value of t can be calculated from this relation. So t is 0 raised to 4, that is simply 0. and when x is 1, then t is 1 raised to 4, that is simply 1. So when x goes from 0 to 1, t also changes from 0 to 1, right? So the limits remains the same. So we can now write this integral I in terms of t, right? So we can now write t is equal to 0 to t is equal to 1, and we have square root of 1 minus t. For x raised to 4, we'll write t, and for dx we can write 1 over 4 t raised to minus 3 by 4, and here we have dt, right? So now this integral is reduced to this one by the method of substitution. So let us rearrange the terms so that we can form this type of integral, right? So we can take 1 by 4 outside the integral, and we have 0 to 1, and here we can write t raised to minus 3 by 4, and square root of 1 minus t can be written as 1 minus t raised to half, and here we have dt, right? Okay, now here let us compare this integral with this one. Here we have 0 to 1, and here we have t raised to m minus 1. Here we have t raised to minus 3 over 4. Here we have 1 minus t. Here also we have 1 minus t, but here the exponent is n minus 1. Here we have half. So let us find out the values of m and n. So m minus 1 can be equated to minus 3 by 4, and n minus 1 can be written as half. So solving these two equations for m and n, from here we can write m is equal to minus 3 by 4 plus 1, that is minus 3 plus 4 over 4, that is 1 over 4. From here we can write n is equal to half plus 1, that is 1 plus 2 over 2, that is 3 over 2, right? So now we can write 1 over 4, then we have 0 to 1, and t raised to minus 3 over 4, and here minus 3 over 4 is m minus 1. M is 1 over 4, so this exponent can be written as 1 by 4 minus 1, and then we have 1 minus t raised to half. So half is n minus 1. So n is 3 by 2, so here we have 3 by 2 minus 1, right? So we have now expressed this integral uh, in terms of, or in the form of the beta function, right? And here we have the additional factor 1 over 4. So now we can write 1 over 4, and m is 1 by 4, and n is 3 by 2. So we can now write beta 1 by 4, comma, here we have 3 by 2, right? So now the value of this integral is given by this expression, and let us calculate the value of this beta function using this result. So now we can write this integral I as 1 over 4. Then we have gamma 1 over 4, and then we have gamma 3 by 2, and in the denominator we have gamma 1 by 4 plus 3 by 2, right? Now 1 over 4 plus 3 by 2 can be written as, taking the LCM here, 4, then we have 1 plus 6, so this is 7 over 4. So now we can write this integral I as 1 over 4, gamma 1 over 4 times gamma 3 by 2 divided by gamma 7 over 4. Now let us write the values of gamma 3 by 2 and gamma 7 over 4, because here we are going to express this integral I in terms of gamma 1 over 4. So now we know an important relation, that is gamma n plus 1 is given by n times gamma n, right? So here in the list of these three important results, we can also add this one. So gamma n plus 1 is equal to n times gamma n. So gamma 3 by 2 can be written as gamma half plus 1, because we can split 3 by 2 as half plus 1. So our n is now half. So we can now write half times gamma half, and gamma half is equal to square root of pi. So we can now write half times square root of pi, right? Okay, now let us write the value of gamma 7 by 4. So we can now write gamma, and here 7 by 4, we can split this 7 by 4 as 3 by 4 plus 1, because 4 times 1 is 1, 4, 4 plus 3 is 7. So we can again make use of this result. So our n is 3 by 4. So here we have 3 by 4 times gamma 3 by 4, right? Okay, now let us make use of Euler's reflection formula, right? Because we have to express gamma 3 by 4 in terms of gamma 1 over 4, right? So here we can substitute n is equal to 1 by 4. So the Euler's reflection formula is gamma 1 minus n, gamma n is equal to we can write pi over sine n pi. So let us substitute here for n 1 over 4. So gamma 1 minus 1 over 4, then we have gamma 1 over 4, then we have pi divided by sine pi over 4, because n is 1 over 4. Now sine pi by 4 is sine 45 degrees, and sine 45 degrees is equal to 1 over square root of 2. So we can now write here 1 over root 2. So taking square root of 2 to the numerator, we can now write pi times square root of 2. So now here we have gamma 1 minus 1 by 4. So this is gamma 3 by 4. And here we have gamma 1 over 4. And in the right hand side, we have pi times square root of 2. So now from this relation, we can now write the value of gamma 3 by 4. So we can now write gamma 3 by 4 is equal to pi root 2 divided by gamma 1 over 4. So now substituting the value of gamma 3 by 4 in this relation, we have here the value of gamma 7 by 4 as 3 by 4 times, then we have pi root 2 divided by gamma 1 over 4. So now we can rearrange the terms. So we have 3 pi root 2 divided by 4 times gamma 1 over 4. So now let us substitute the value of gamma 7 over 4 in this relation, and then we'll also substitute the value of gamma 3 by 2, that is half root pi. So now we can write I is equal to 1 over 4. Then we have gamma 1 over 4, and gamma 3 by 2 is half root pi. And then we have gamma 7 over 4 as 3 pi root 2 divided by 4. And then here we have gamma 1 over 4, right? So let us rearrange the terms. So we have 1 over 4, then we have gamma 1 over 4, then we have half root pi, and taking 4 times gamma 1 over 4 to the numerator, that is we can now write 4 times gamma 1 over 4, and here we have in the denominator, that is 3 pi root 2. So now here this 4 and this 4 get cancelled, and here we have gamma 1 over 4 times gamma 1 over 4. So we can now write gamma 1 over 4 square, and then here we have root pi, and in the denominator we have 2 times 3, that is 6, and we have 6 pi root 2. So now see, here we have pi raised to 1, right? And we can now write gamma 1 over 4 square, and then we have 6 root 2, and here we have root pi over pi, right? And using the laws of exponents, we can now write 1 over pi 1 minus half, right? And this is 1 over this is 1 minus half, that is simply pi raised to half, that is 1 over root pi. So we can now substitute the value of root pi over pi as 1 over root pi. So we can now write gamma 1 over 4 square, and then we have here 6 root pi times root 2. So now we can combine these two terms, because here we have square root, here also we have square root. So we can now write gamma 1 over 4 square, and then we have 6 times square root of 2 pi. So viewers, the value of this integral is square of gamma 1 over 4 divided by 6 times square root of 2 pi. So viewers, this is how by the application of beta and gamma functions, we can easily evaluate integrals of this kind. So the value of this integral I is gamma 1 by 4 square divided by 6 times square root of 2 pi. Hello viewers, in today's session we are going to discuss another important problem from integration, and here we have to evaluate this integral, that is from 0 to infinity, and we have x raised to 5 divided by 1 plus x cube raised to 5 over 2 dx. And here we are going to make use of the concept of beta and gamma functions to evaluate this integral. And before applying the concept of beta and gamma functions, let us first make use of the method of substitution to convert this integral into a beta function, that is beta m comma n is given by the integral, that is 0 to infinity, and we have t raised to m minus 1 divided by 1 plus t raised to m plus n dt. So by a method of substitution, we'll first convert this integral into the beta function. So now let us first substitute t is equal to x cube, right? So that this term becomes 1 plus t raised to 5 over 2. So we'll take t is equal to x cube, and this implies that x is t raised to 1 over 3. So let us differentiate x with respect to t. So we have dx over dt is d by dt of t raised to 1 over 3, and making use of the power rule, we have nt and n minus 1, right? So here the value of n is 1 over 3, so we have the derivative of t raised to 1 over 3 with respect to t as 1 over 3 t raised to 1 over 3 minus 1. So this is 1 over 3 t raised to 1 minus 3 over 3, 1 over 3 t raised to minus 2 over 3. So now dx over dt is equal to this expression. So now we can write dx is equal to 1 over 3 t raised to minus 2 over 3 and dt. So now let us change the limits accordingly. So here x varies from 0 to infinity, right? So when x is 0, 0 is the lower limit. The value of t can be obtained from this relation. So we have 0 cube, that is 0, and when x tends to infinity, that is the upper limit, then t also tends to infinity due to this result, right? So now let us write this integral I in terms of t. So we can now write 0 to infinity, and then we have x raised to 5, x is t raised to 1 over 3. So we have t raised to 1 over 3, and here we have 5. For dx, we can now write 1 over 3 t raised to minus 2 over 3 dt. And in the denominator, we can write 1 plus t raised to 5 over 2. So now let us arrange the terms here, and we can simplify. So we can take 1 over 3 outside the integral. We have 0 to infinity. Then here we have t raised to 5 over 3, and here we have t raised to minus 2 over 3, and here we have 1 plus t raised to 5 over 2 and dt. So now we can write I is equal to 1 over 3, 0 to infinity, and here we can apply the laws of exponents. So here the base is same, so we can add the powers. So we have 5 over 3 plus minus 2 over 3, that is 5 minus 2 over 3, that is 3 over 3, and that is t raised to 1, right? So in the numerator we have t raised to 1, and here we have 1 plus t raised to 5 over 2 dt. So now let us compare this integral with this one, right? So here we have 0 to infinity, here we have 0 to infinity and t raised to 1. Here we have t raised to m minus 1, and here we have 1 plus t raised to 5 by 2, and here we have 1 plus t raised to m plus n. So let us find out the values of m and n in order to express this integral in this form. So we can now compare both these integrals. So we have m minus 1 is equal to, so we have m minus 1 equal to 1, and then m plus n is equal to 5 over 2. So let us solve this equation. So we have m is equal to 1 plus 1, taking minus 1 to the right hand side. So we have 2, and then taking m is equal to 2 in this equation, we have 2 plus n is equal to 5 over 2. So n is 5 over 2 minus 2, that is 5 over 2. This is 4, and 5 minus 4 is 1. So we have 1 over 2. So now we can write this integral I as 1 over 3, 0 to infinity, and t raised to 1. So 1 can be written as m minus 1. So m is 2, so we can write 2 minus 1, and here we have dt, and 1 plus t raised to 5 over 2. So 5 over 2 is m plus n. M is 2, and n is given by half, right? So now this integral is exactly of this form. So now the value of m is 2, and the value of n is half. So this is our beta function. So we have 1 over 3 times the beta function m comma n. M is 2 and n is half. So let us now calculate the value of this beta function with the help of this important relation between beta function and gamma function. So beta function is equal to gamma m times gamma n divided by gamma m plus n. So here we have 1 over 3, and then we can now write gamma 2, then we have gamma half, and in the denominator we can write gamma 2 plus half. So we can now write the value of I as 1 over 3, and gamma 2 is equal to 1, because here we can use this result gamma n plus 1 is equal to n factorial, where n is some positive integer. So if we take n is equal to say 1, then here we have 1 plus 1 2. So gamma 2 is 1 factorial, that is simply 1, right? And here we have gamma half. So gamma half can be written as square root of pi. So here we have square root of pi, and in the denominator we have gamma of 5 over 2. So now let us write the value of gamma of 5 over 2 with the help of this relation, that is gamma n plus 1 is n times gamma n. So here gamma 5 over 2 can be written as 3 by 2 plus 1. We can split 5 over 2 as 3 by 2 plus 1. So now our n is 3 by 2. So taking n is equal to 3 by 2, in this relation we have 3 by 2 gamma 3 by 2. And further we can split 3 by 2 as half plus 1. So now we have 3 by 2 half times gamma half. So again applying this result to this expression. So now we have 3 over 4 gamma half. Gamma half is square root of pi. So substituting the value of gamma 5 over 2 as 3 by 4 times square root of pi, we can now write the value of I as 1 over 3. This is root pi, and here we have 3 by 4 times square root of pi. So these two terms get cancelled, and we have 1 over 3 times 4 over 3. So we'll take the reciprocal of 3 by 4. So here we have 4 over 9. So viewers, the value of this integral is equal to 4 divided by 9. Hello viewers, in today's session we are going to discuss another important problem from beta and gamma functions. And here once again we are going to apply the concepts of beta and gamma functions to evaluate this integral. So here we have to evaluate this integral from 0 to 1, and we have x raised to 4 divided by the cube root of 1 minus x cube square, right? So let us call this integral as I, and let us start with the method of substitution, right? Because our aim is to convert this integral into the beta function, that is beta m comma n is equal to the integral 0 to 1, and we have t raised to m minus 1 1 minus t raised to n minus 1 dt, where m and n are greater than 0, right? So the first step is to convert this integral into the beta function by a method of substitution. So now let us substitute here. X cube is equal to t, right? So here we'll introduce this variable t such that x cube is equal to t, or x is equal to the cube root of t, right? So let us differentiate x with respect to t. So we can now write dx over dt is equal to d by dt of t raised to 1 over 3, and using the power rule for differentiation, we know that the derivative of t raised to n with respect to t is n times t raised to n minus 1. So here n is 1 over 3, so we have 1 over 3 t 1 over 3 minus 1, and this is 1 over 3 and t, and here we have 1 minus 3 over 3, that is 1 over 3 t, and minus 2 over 3. So now we can write dx is equal to 1 over 3 t raised to minus 2 over 3 and dt, right? So now let us change the limits accordingly. So here the lower limit is x is equal to 0 and the upper limit is x is equal to 1. So when x is equal to 0, then the value of t can be obtained from this expression. So we have x is equal to 0, so 0 cube is 0, and when x is equal to 1, then the value of t is equal to 1 cube, that is equal to 1. So when x goes from 0 to 1, then t also changes from 0 to 1. So now we can easily write this integral I in terms of t. So we have t is equal to 0 to t is equal to 1, and for x we can write t raised to 1 over 3 raised to 4, and here we have x raised to 4, so taking x is equal to t raised to 1 over 3, and then we have the cube root of 1 minus x cube square. For x cube we can write t, and here we have square, and for dx we can write 1 over 3 t raised to minus 2 over 3 and dt, right? So now let us simplify this integral. So now we can write this integral I as 0 to 1, and here we can take this term 1 over 3 outside the integral. Then we have t raised to 4 over 3. Here we have t raised to minus 2 over 3 dt, and in the denominator we can write 1 minus t square, and here we have the cube root, so here we can write 2 over 3. So now this is 1 over 3 0 to 1, and here using the laws of exponents, we can write t raised to 4 over 3 minus 2 over 3, that is t raised to 4 minus 2 is 2, so this is t raised to 2 by 3. So here we have t raised to 2 by 3, and taking this term to the numerator we have 1 minus t raised to minus 2 over 3 dt. So now what we have to do, if we see this integral and this integral, then we can easily conclude that here we have m minus 1, and here we have 2 over 3, and here we have 1 minus t raised to n minus 1, and here we have 1 minus t raised to minus 2 over 3. So let us write this exponent, that is 2 over 3 is equal to m minus 1, right? So we can solve this equation. So we have m is equal to 1 plus 2 over 3, that is 3 plus 2 over 3, that is 5 over 3. And similarly here we have minus 2 over 3, and here we have n minus 1. So solving this equation for n, we can now write minus 2 over 3 plus 1. So this is minus 2 plus 3 over 3, that is 1 over 3, right? So now we can write this integral as 1 over 3 0 to 1, and t raised to 2 over 3 can be written as m minus 1, right? Because we want to convert this integral into this form. So 2 over 3 is equal to m minus 1 and m is 5 over 3. So we can now write t raised to 5 over 3 minus 1, because 5 over 3 minus 1 is again 2 over 3. And then we have 1 minus t raised to minus 2 over 3, and n is 1 over 3, so minus 2 over 3 is 1 over 3 minus 1, and here we have dt, and 1 over 3 minus 1 is minus 2 over 3. So now this integral is similar to this one, that is this is the beta function. So now we can write 1 over 3, and this integral is equal to the beta function, that is beta m comma n. So here m is 5 over 3 and n is 1 over 3. So now we have to calculate the value of this beta function by using the relationship between beta function and gamma function. So now the beta function and gamma function are related by this expression, that is gamma m, then we have gamma n divided by gamma m plus n. So now this integral I is equal to 1 over 3, and beta 5 over 3 comma 1 over 3 is equal to gamma 5 over 3. Then we have gamma 1 over 3, and here we have gamma 5 over 3 plus 1 over 3, right? So this is 1 over 3 and gamma 5 over 3, and then we have gamma 1 over 3, and here 5 plus 1 is 6, 6 over 3 is 2, so we have gamma 2. So now to get the value of gamma 5 over 3, let us make use of this important result, that is gamma n plus 1 is equal to n times gamma n, right? So if we take gamma of 5 over 3, then gamma 5 over 3 can be written as here we can write 2 over 3 plus 1, right? So we can split 5 over 3 as 2 over 3 plus 1. So if we compare this expression with this one, then n is 2 over 3. So here we can now use this expression. So we have 2 over 3 times gamma 2 over 3, and gamma 2 is equal to 1, because we know that gamma n plus 1 is equal to n factorial when n is a positive integer, right? So gamma 2 can be written as gamma 1 plus 1, and that is 1 factorial, that is equal to 1. So now we can write this expression as 1 over 3, gamma 1 5 by 3 can be written as 2 over 3, gamma 2 over 3, and then we have gamma 1 over 3, and in the denominator we have 1. So now here we can multiply these two fractions, so we have 2 over 9, and then we can now write this 2 over 3 as 1 minus 1 over 3, right? So the purpose of writing 2 over 3 as 1 minus 1 over 3 is to make use of the famous Euler's reflection formula. So gamma 2 over 3 can be written as 1 minus 1 over 3, and here we have gamma 1 over 3. So now let us look at this expression. So we know that from Euler's reflection formula, that is gamma 1 minus n times gamma n is equal to pi over sine n pi, right? So if we take n is equal to 1 over 3, then this left hand side it appears as 1 minus 1 over 3, then we have gamma 1 over 3, and here we have pi over sine n pi. So n is 1 over 3, so we have sine pi by 3. So now we have pi, and sine pi by 3 is sine 60 degrees, that is root 3 over 2. So we can now write 2 pi over square root of 3. So now the value of the integral I is equal to 2 by 9 times gamma 1 minus 1 over 3 times gamma 1 over 3, and the value of this expression is equal to 2 pi over square root of 3. So we can now multiply 2 and 2 pi, so we have 4 pi over 9 root 3. So viewers, the value of this given integral is given by 4 pi divided by 9 times square root of 3. Hello viewers, in today's session we are going to discuss another important problem from integrals, and in this session we are going to find out the value of this definite integral using the concept of beta and gamma functions, right? So here we'll see the application of beta and gamma functions to evaluate this integral, right? So here we have the integral from 0 to 4 x raised to 3 by 2, and here we have 4 minus x raised to 5 by 2 dx. So first we'll convert this integral into a beta function by using the method of substitution. So let us start. So let us first call this integral as I, right? And here we'll make this substitution, that is x is equal to 4 times t, right? So here we are using this substitution because we wish to convert this integral into this form, that is the beta function, that is beta m comma n, and here we have 0 to 1 t raised to m minus 1 and 1 minus t raised to n minus 1 dt, where m and n are greater than 0. So making this substitution, we'll first convert this integral into this form, and then we'll apply the relationship between beta and gamma functions, that is beta m comma n is given by gamma m gamma n divided by gamma m plus n, right? And moreover here we'll also utilize these two important results, that is gamma n plus 1 is given by n factorial, where n is some positive integer, and gamma n plus 1 can also be written as n times gamma n, right? So let us make this substitution. So here x is equal to 4t, so t can be written as x over 4. Now let us differentiate x with respect to t. So we can now write dx over dt is d by dt of 4t, and we have 4 times the derivative of t, and derivative of t with respect to t is 1, so we have 4. So now a dx can be written as 4 times dt, right? Okay, now let us change the limits, because here x varies from 0 to 4, and here we can find out the value of t using this relation. So when x is equal to 0, then t is 0 over 4, that is 0, and when x is 4, then t is 4 over 4, that is 1, right? So now let us write this integral I in terms of t. So we can now write the limits from 0 to 1, because when x changes from 0 to 4, t goes from 0 to 1. So we have here 0, here we have 1, and x raised to 3 by 2. So x is given by 4 times t. So we can now write 4t raised to 3 by 2. Then we have 4 minus x is 4t raised to 5 over 2, and dx is given by 4 times dt, right? Okay, now let us arrange the terms or simplify this expression or integrand. So we have 4 raised to 3 by 2, and then t raised to 3 by 2. So distributing this power to 4 and t, and here we can take 4 common. So we have 4 minus t raised to 5 over 2, and here we have 4 dt. So now we can write 0 to 1, 4 raised to 3 by 2, t raised to 3 by 2, and then this exponent can be distributed over 4 and 1 minus t. So here we have 4 raised to 5 by 2, 1 minus t raised to 5 over 2, and here we have 4, which can be written as 4 raised to 1, and here we have dt. So now let us first collect these fours, right? So we have I is equal to 4 raised to 3 by 2 plus 5 by 2 plus 1, and taking this term outside the integral, and then we have 0 to 1, t raised to 3 by 2, 1 minus t raised to 5 over 2, and here we have dt. So now this expression is equal to 4 raised to 5, because here 5 plus 3 is 8, 8 over 2 is 4, 4 plus 1 is 5, and we can now write 0 to 1 and t raised to 3 by 2. So 3 by 2 can be written as 5 by 2 minus 1, because we have to write this exponent, that is m minus 1. So we have to write 3 by 2 in this form, m minus 1. So 3 by 2 is 5 by 2 minus 1. And similarly, here we have 1 minus t raised to 5 by 2. And 5 by 2 can be written as 7 over 2 minus 1. And here we have dt. So now this integral is is converted into this form, which is similar to the beta integral. So now 4 raised to 5 can also be written as 2 square raised to 5. So we have 2 raised to 2 times 5 is 10. So here we have 2 raised to 10, and here the value of m is given by 5 by 2, and the value of n is given by 7 over 2. So this integral is now equal to the beta function, that is beta 5 by 2 comma 7 over 2. And here it is quite obvious that 5 by 2 and 7 by 2 both are greater than 0 or positive. So now to calculate the value of this beta function, we have to make use of this result. So we have 2 raised to 10, then we have gamma m. Gamma m is gamma 5 by 2. Then we have gamma 7 over 2 divided by gamma 5 over 2 plus 7 over 2. So now the integral I can be written as 2 raised to 10. Then we have gamma 5 by 2 and gamma 7 over 2 divided by this is 7 plus 5 12. 12 over 2 is 6. So we have gamma 6, right? So now let us find out the values of these three terms using these relations. So gamma 5 by 2 can be written as gamma 3 by 2 plus 1. So here we have gamma n plus 1, which can be written as n times gamma n. So n is 3 by 2, so we can write 3 by 2 gamma 3 by 2. Then we can further split 3 by 2 as a half plus 1. So again, applying this result to gamma half plus 1, we have 3 by 2 times half, then we have gamma half, and gamma half is equal to square root of pi. So we have 3 by 2 times half times root pi, that is 3 over 4 times square root of pi. And similar is the case with gamma 7 over 2. This can be written as 5 by 2 plus 1. So we have again applying this result to gamma 5 by 2 plus 1. N is 5 by 2, so we can write 5 by 2 gamma 5 over 2, and gamma 5 over 2 is given by 3 by 4 times square root of pi. So here we have 5 by 2 times 3 by 4 root pi. So this is 5 times 3 is 15 over 8, and here we have root pi. And now gamma 6 can be written as gamma 5 plus 1. So here we can apply this result. So n is 5, which is a positive integer, so we have 5 factorial. So 5 factorial is 5 times 4 times 3 times 2 times 1. So this is 120, right? So now let us substitute these values in this expression. So I can now be written as 2 raised to 10. Then we have 3 by 4 root pi. Then we have 15 over 8 root pi divided by 120. So now our aim is to simplify this expression. So we can now write I is equal to 2 raised to 10, and here in the numerator we have 3 times 15. That is we can write 3 times 15. Root pi times root pi is simply pi, and in the denominator we can write 4 times 8 times 120. So now this is 15 times 8 is 120. So we can cancel 120 with 15. So we have here 8. So now we have 2 raised to 10 times 3 pi, right? 3 times pi. And here we have 4 times 8 times 8. So 4 can be written as 2 square, then 8 is 2 cube, then 8 is again 2 cube. So we can now write 2 raised to 10. Here we have 3 pi divided by 2 raised to, again applying the laws of exponents. So this is 3 plus 3 is 6. 6 plus 2 is 8. Right? So now the value of the integral I is 2 raised to 10 minus 8. So subtracting 10 and 8, and then we have 3 pi, and 2 raised to 10 minus 8 is 2 square, and here we have 3 pi. So 2 square is 4. 4 times 3 pi is 12 pi, right? So viewers, the value of this integral I is equal to 12 times pi.